I'm gonna start right away with some example classes because today we're gonna need a lot of example code, or at least a couple of different lines that are tedious to write down, but that's a plot point, so to speak. First we're gonna make class monster, which is gonna be our parent class, and then we're gonna make some monsters. We start with slime, which is a monster, and we're gonna make, let's just copy mimic and skeleton. Skeletons are monsters. And the dragon, we need a boss monster as well. And also I want to have an enum, public enum monster types, which catalogs all the different monsters I have, for example slime. And then a static method in monster, quick static monster, create monster, which receives a type of monster, and then based on that creates a new monster. For example, for slime, we return a new slime, which is a type of monster, so that's fine. And if we don't recognize anything, but throw new argument of range exception, that should be fine. No, that's types. It's not a valid monster type. Right, and why is this? Oh, wrong slime. This is the correct one. Okay, so simple code. I would be able to go to monster.createMonster, give it a slime, and get a monster. So let's just check that. Compiling the code. It worked, and if we look at monster, you can see on the right, monster is a slime. It's stored in monster, but internally it's of type slime. So everything worked, that's good. Now we just have to repeat these same steps for all the other monsters. And there are only 3, but there might be more in the future. And why do you still the debugger in? Weird. So let me just try that again. Does it not disappear? Right. You did see the debugger stuff in here, right? If I click in here? No, you don't. Why? Okay, you know what? Let's just hide the console. We don't need it anyway today. Let's try it again. So, monster is type slime. You can see it up here in the debugger view. And down here you can see it's of type slime. So it worked. And now I have to do the same for all these monster types. But I'm too lazy to do that, and maybe there are monster types in the future that I need to add, and I might just forget to do that in here, and maybe there are more than 3 that I've already ready. And again, nowadays people probably would use something like AI, which, why? There's a much simpler way to, okay, admittedly not simpler, but there's another way you can do that, something that I do quite a lot actually. And that is more reliable, I think, than AI, and doesn't require much typing anyway. So instead of writing a prompt, you just write a few lines of code. And what we do is we're gonna start by getting, during the runtime, a reference to the assembly our code is running in. Remember, when we compile this code, what we're generating is a single binary file, or a library. So in this case, It's a console application. We're generating an executable. It's a console program. Executable you can run on Windows. Otherwise, we might run the compiler to generate a library, a DLL. And for the most part, unless you specified, each project in your solution will refer to one exact assembly later on. That can be the library or an executable. They all are just assemblies. And we want a reference to the very assembly that all our monsters are defined in, which is the same assembly we run our code in. For that we have a special type, assembly. And there are some static methods in here we can use. I'm gonna use this one, getExecutingAssembly, which gets us an instance of assembly, but specifically the assembly that this method is currently running in. So wherever this main method is defined, wherever we called it, that's where the executing assembly refers to. There is also calling assembly. That would be basically our parent if we had one. Now, in this case, we are in the main method. This is the entry through the program, so we are the first assembly that's loaded and starts calling. But if you use this in a library, you would actually get the assembly that called the method in your library. So I might have some executable outside with a main method, and that calls code inside in the library. And inside that library, this call would reference your main assembly again. Should probably write that down somewhere a bit better. Let me just finish this. Lastly, there's getEntryAssembly. And this one refers to the very first assembly that was loaded. Basically the one that started your program, which is again the main method, or where the main method is defined. Usually it doesn't always have to be the case. There are special circumstances, which is why this doesn't work right now, because this can actually return null. These two are guaranteed to give you an assembly because there has to be an assembly, but there's no other way. Something has to call us. The entry assembly is a bit weird because that refers to the entry into your program, which has potentially weird circumstances, which I don't ever encounter. I'm not mucking about with that part of C#, so nah. But it's there. And usually getEntryAssembly will work. Though you can just check for null and act accordingly. I use getExecutingAssembly to get the assembly my code is currently running in. And this executing assembly now lets me do some interesting things, like calling this method getTypes, which gets me an array full of types with a C# type, or type, which is a class that basically contains all the metadata for each C# class you might have, or not just C# classes, also structs and interfaces, all the top level structures. I'm missing the word. What's the name for that? Things like class and struct and enum and interface. God, I forgot the name. Well, all of those are types. And this type contains all the meta information. It contains the name and where it was defined and any special properties it has, and actually what properties it has and what methods, and everything you might need to know is all contained in a type that you can reference during the runtime. So this code allows me to reference the types in the very code I'm running right now. It reflects the program itself. This is a so-called reflection. or we're using reflections in general right now. We're using C# code that can analyze and watch over and manipulate itself. We specifically engage with the language component, not with some data anywhere in memory. We look specifically at the program as the runtime might look at it. Well, not exactly like that. It's a bit higher level, but we now have access to all the details of our code, which lets us do some crazy things. Some also not so good things. We'll look at that a bit later. But let me just iterate through the different types, which is all the types defined in our assembly. So program is one type, monster type is a type, monster is a type, and of course slime, mimic, skeleton, and dragon are also types defined in our current assembly. All are part of this one assembly that I defined here, because they're all part of this one project, and by default this one project results in one assembly. Now I can do things with this type. I can, for example, get the base type for that type, which means for things like slime, mimic, and skeleton and dragon, base type is the type, again, just another type instance, for their parent class, basically. So all of those would have base type monster. As you can see, it's nullable because not every type necessarily has a base type. So in those cases, this would be just null. And what I want to do is I want to compare this to the type of monster. And if it's not monster, if it doesn't have monster as the base type, if it's not inheriting from monster directly, we'll just ignore the type and continue to the next one. But if it is directly inheriting from monster, I want to quickly output that. Right line. Let's first take care of the enum. All I want to do here is just type.name, which would be, for example, slime or mimic, and add a comma behind that, and I put that in different lines. And what I get with that is the code finished. Okay, now the line was mixed in between, but you can see slime, mimic, skeleton, dragon. I can copy that was the wrong button. Yeah, I have to just delete that line, but I can copy paste that in here. Let me just quickly remove that line. And I have all my types for my enum neatly arranged. Let's remove the last one. I don't like that. So that's that. And we can also create the cases here. So let's just do case type.name. Well, type.name is not correct because we do need to add the monster types in front, which we can just do like this. We're just writing out text that happens to match the exact text we need to paste in our code. And we can also just copy this now, do a new line, slime, and instead of slime we do type.name. And so when I execute this now, why is it not? Okay, something happened to my keyboard, it's not doing the thing. Okay, but now we have the output here. Okay, let's... Okay, can I do that up here? Red... Sleep. I'm not sure if that will fix things, just to make sure. Yeah, that's better. Give it a bit of time in front and ahead. After. Okay, but with that, we just generated code. We can just copy and paste in here, and all of our types are taken care of. And honestly, it's just a few lines of code. I wouldn't even write out all of this stuff. I would just do this, get types, have a simple loop, just filter out what I want. In my case, it's pretty simple. I can directly check base type, and I'm done with it. And that way I can quickly generate myself some simple, repetitive code. And I can be damn sure that this is correct. And not like with AI, where I have to double check, did it actually use the right values? Did it not mix anything up? Did it forget anything? Is that too much? No. It's, yeah, pretty clearly defined in here what we want. And that's also just a few lines of code, which might be easier and quicker to type out than to explain that to an AI in the prompt. Just saying. Okay, but enough AI hate. This is one of my main applications for reflections. It is pretty simple, pretty stupid, and it's just a very convenient tool. That's not where you actually use it though. That's one possible use. But let's forget about that here. And let's look at this a bit more. Right now, I'm using monster type in enum, and based on the enum value, I call a different constructor. The first thing I might realize after implementing this, the monster type doesn't really have any use for me. Instead of having a specific enum, just maybe I want to simplify it to just a string. Which might also make it easy to integrate that with some internal debug console for your game, where you can just type in something and suddenly you spawn a different monster without parsing an enum or anything. So, okay, that means we just change the code to this then, potentially. But that still means we have this switch case which has to list everything. So if we suddenly want to add additional code that provides more monster types, well, this create monster needs to be rewritten. Every time we add a new monster or change any existing monsters, we have to rewrite this entire part. And that also means once it's compiled, it's set in stone. And if you later on extend your program with some additional libraries after it's installed, it will not react to that. So instead of having a static switch case in here, we want to make things a bit more dynamic. And we can do that again with a reflection. Let me go again, assembly.getExecutingAssembly, wherever we are currently in. That's the assembly we want to look at. That's not the only way to get the assembly, by the way. Just it's the one I'm using for now because you've seen it already. And we're gonna go through all the types, same as before. And we're gonna filter again. If not, type.baseType equals type O. That's a type I. Monster. Continue. Oh, actually, wrong knot. There. Simple filter, which we can expand now if it doesn't have the base type monster or type.name isn't actually. Let's rename this quickly, not types, it's monster type, singular. Then continue. And otherwise, we know that type, if we go to this line, if this if didn't trigger, we know that type is the exact type in our class or in our assembly that inherits directly from monster and has the given string as a name. So if I go slime in here, it's the string, we know we will eventually reach a point where this loop hits slime, the type of slime, and we'll enter this part of the code because it is directly a child of monster and its name is slime. what now? We want to create a monster. We want to call its constructor. But all we have is so far is the type. There are two ways we can tackle this. Well, technically there are three ways, maybe even more. But if we want to have it simple, there are two ways we can do this. The first one I'm going to use is using a class called Activator, which is more or less specialized for this one thing. It has three different methods, and the one we're going to use is called CreateInstance, which just receives a type. It has other parameters we can give it, but in the simplest form, this is all we need to do. We just give it exactly the type we want to create, and it will create an object that is generated by calling the default constructor of that type. Note how neither monster nor any of these subtypes override their default constructors. So all of them can be created with just new slime, new mimic, whatever. That's what we did in the switch case earlier as well. So Activator will have no trouble finding out what constructor to use. Again, you can override this, you can do some other things here, but in the end, you're looking for just the default constructor that you want to call, and you create the type internally. But CreateInstance is a method that can be used on any type. So the return value is not the type directly. This is not slime, which doesn't make sense, or even monster. This is just very generic object. So we need to cast it into the proper type we want. Now generally, we could just go for monster, for example. We know whatever we create inherits from monster. It's gonna be a type of monster. We can safely cast it to monster, in theory. CreateInstance, however, can also fail. And that can happen both in the sense that it just has an exception, or that we get a null back. And so what we actually would need to do here is either create a nullable, or what I'm gonna do, catch the null early, and in my case I'm gonna do an exception. Operation exception. Let's see. Type is not valid monster. Like that. And now I can actually save it as monster and also just directly return it if I want to. And if we end it down here, that means none of the types fit our criteria, and we'll just throw the exception directly, because we don't know any types that match this name. It's not a monster type. Yeah. Let's do it like that. So, create monster, I'm just setting a breakpoint. Just gets the string slime. That works. We get a monster back, and it's of type slime. Let's try... not again. Right. Let's try dragon. And this time we get a dragon back. So, cool, that worked. Let's do... what's another classic monster type? Goblin. This time we get an exception down here, because none of the types we found matched the name Goblin. If I do have a Goblin class, however, this code works again. Directly can react to the new class that we added. Very dynamic. The other method we had was to, well, more or less skip all of this. We could use the assembly directly. So let me do assembly again. Actually, let's make this one a bit different. Type of monster. I can use type of to get just a type. And so I can also do type of monster.assembly. Every type has an assembly where it's defined. And you can see, why is it still there? I can... It's always popping back up. It's not supposed to. Wait, just let me quickly... Can I turn this? Nope, that's not it. Why does it not work? Why doesn't it work? Can I just... Let's just do it like this, whatever. Did you miss? So I use type of to get the type, and then .assembly to get the assembly where this type originates in. Every type is defined once in one assembly that is known at runtime. Well, sort of. A type can exist, well, not the type directly. A specific type only can exist in one location. You can have different types with different names if they originate in different assemblies or have different namespaces. Look, doesn't matter. We are referring to monster, this class specifically, and we're getting its assembly. So we're getting our current assembly. It's going to be effectively the same as getting executing assembly, but there's a subtle difference. These are only guaranteed to be the same because we're calling executing assembly inside the class monster. So we know it has to be the same assembly where monster is also defined. And assembly also has a create instance that we can use, like Activator. This one is a bit more specific though. If I were to just try monster type, and let's quickly pass it to monster. And return. Actually, we can copy this part down here as well. Create instance here can also return a null. It's also returning an object otherwise. And all of this code will be basically ignored. Let's go back to slime as well and call, and this will not work. Okay, this will not work because, why is it member info? When did I change that code? Okay, again. So we get an exception here. Slime is not a valid monster type, despite a class slime definitely existing. And the code would work just fine if we didn't use this line. So this code can find the slime class. This code doesn't. The difference being the create instance got the type directly. Type. An instance of type with all the meta information it needs. Create instance for the assembly gets only a string. And again, why is the console always popping up? That's annoying. That's very annoying. Okay, wait. No, I can change this. This should be it. Let's hide that. Okay, let's just try it. It should not come back up. It did come back. Why? I turned you off. Why? How can you come back up? Okay, let's try this again. Okay, now it worked. My God. That took some technology. All right. So the code works just fine if we don't have this line, but it doesn't work if we use this line as it is. Because Activator gets the full type, which has all the meta information. we tie it down to one type specifically, but CreateInstance for the assembly gets only a name. And that's not very explicit, because there could be many instances of, or many different types with the same name, as long as they have a different namespace. Creating another class slime in here is a problem, but if I create a new namespace, I can have another slime, because that's just part of the name now. CreateInstance wants the full name. That means I would need to add right now the namespace to type, and now it can actually create it. So CreateInstance can be used, but you have to be careful with what you pass in. It's not actually asking for the name of the type, it's asking for the full name. That means the namespace and its actual class name. And then there's the fully qualified name, which is a bit more. We don't need to get into that. Okay, so this code is pretty dynamic and creates a monster of a specific type, which can be added during runtime. Cool. We can just add new classes, and we still have a static method in monster that can create those monsters. Let's say those monsters actually need to do something as well, and we still want to execute that from within the static method. Let's say a slime has a public void greet, which receives a message they're supposed to output. Slime says message. Like that. Only slime has it, the other monsters don't have it. We still want to call it. The classical choice would be I'm making this greet method a virtual method. Public, oh, let's go back. Public void, public virtual void, greet, and so on, and then just overwrite down in slime, and then I can call it directly on the return type I get here. Actually, let's take care of that as well. I'm gonna store a monster. No, it's gonna be a monster. What do we... No, let's do it this way. Monster, and then we're gonna do monster equals that. So let's make a save cast in here. So if the cast doesn't work for whatever reason, it's just gonna use null. And if monster is null, right, so I have to set a default value in case the loop doesn't iterate over that. So I get a monster, and instead of calling now monster.greet, which I could make, I want to call a method that is exclusive to slime, that might exist, might not exist. We're not even sure what the name is going to be. We don't want to tie it directly to our code. We want to, again, make it a bit more loose, be a bit more dynamic. Not sure why, but maybe there are reasons. What I can do is use the type for monster, for the specific type of monster actually, which I can get with GetType. Type. GetType, the method GetType that's available always and everywhere. You can also call it in here just directly. Is gonna get you the type of the class directly. We can store it in a monster, but GetType would give you the actual type. So this would return slime as the type, not monster. So whatever type of monster we got with GetType, we get exactly that. So specific type for us right now would end up as slime. as a reference to the type for slime. And we can use this specific type to get a method from this type with GetMethod. And in the simplest case, this would be just the name of the method. But since we're here, let's also just specify a few other things. Like, for example, this thing is a public method and it's an instance method. I'll do an example for static later, but that would be the option. We have instance because it's an instance method, not a static method, and it is public. Now I also want to specify what type of arguments it accepts. In our case, it accepts a string, so I have to add an array which contains the type for string, the actual type. And all of this together gives us now potentially a MethodInfo object. You can think of type as containing all the meta information for a class, for one of the major structures, the large-scale overarching structures. And MethodInfo contains all the meta information for a specific method, which also includes references like in which class am I written down? Where do I come from? Where do I go? Where do I come from? Whatever. MethodInfo, if we did find a method matching all those criteria, we'll have exactly this method greet in there. If none of the methods matched our filter conditions here, then this will just null. But assuming we did find a method that matches, so in case of slime, this would be filled. In case of mimic, this would be null. If we did find it, we can actually call the method. We can invoke it. Now, it's important to realize this doesn't refer to a specific monster we just created. We have an actual instance of a slime stored in monster, like an actually fully initialized slime. We called the constructor and have it stored in there. Don't think about how we constructed it. This is just a normal slime now, an instance of the class slime. MethodInfo doesn't refer to that one specific instance. This is just meta information about the class and more specifically this method in general. Completely independent from any instances. So when we invoke this method, or we tell the compiler or the runtime later on, figure out this method, figure out how it's defined, how it's set up and what the rules are, and then call this method. And then we have to tell it for which instance we have to call the method, because this isn't tied to any instance specifically. We have to provide it in the method call. We have to tell it this instance for monster, which in our example will be a slime. Call the method in there. Call this exact method that we collectively stored in here or reference in here for this one specific instance. And when you call it, you can give it these parameters. It receives one string, and so we provided one string. And this will call the method. So let's return monster to finish it up. What that means for slime, this will first dynamically find the type where the slime is defined and use Activator to create an instance. And then on that created slime, it will try to find a method named greet that is public and non-static, that accepts one single string, and then it will call that method on that instance of the monster we created using the text hello, and then return the instance. So going to the debugger, we did create a slime, so this is correct. And if we look at the output, slime says hello. So we did create the slime and had it say hello using its declared method. If we go to skeleton. Simple. We do get a skeleton, but there's no output because skeleton doesn't have a method to greet. If it has a method to greet, let's just make one. Make a public method. Let's say this one is actually a bit different. This one has a bool, return value. Greet string, input string, return, input string, length, 0. Also db skeleton, input string. So we get a skeleton and we get the output, and the whole return value didn't matter. That's not part of the signature. So it's a difference. Just because it fits the criteria down up here doesn't mean it's the exact same method. These do look a bit different because one is a void and the other is a bool. But both are named greet, are public, instance-based, and accept a single string. So same signature, both methods are identical as far as this get method is concerned. We can look at the return value though, and then we can see a difference. So for skeleton, the invoke returned a true. We get a value back, the return value of this greet method, which was true. We call the code for the slime, the void method, we get a null. Now to be clear, you can also get a null legitimately as a return value. So just because the return value of invoke is null doesn't mean the method itself is void. If you want to test for that, you can just go MethodInfo.ReturnType, and that tells you what type it is. And if you want to know if it's void, you can specifically go to type of void, because despite meaning that there is nothing to return, there's actually a type in C# system.void that can be referenced as a type. So, whatever. So you can use the MethodInfo return type to check if it does have a return type, and then you can, if you need to, cast the return value of invoke to that type. But we don't need it, so it doesn't matter. In any case, we can dynamically call code. We can dynamically create instances. Let's make things a bit more interesting. So far, what we did could have been accomplished using just good old inheritance. Polymorphism. We can just have slime and skeleton both inherit from monster and override the greet method. I mean, the different return types, that's a bit different. You would have to use some different names, but in general, possible. Let's say that the different methods all have public, static, slime. No, not public, static, slime, create, like that, and returns new slime. So let's say the constructors are hidden and you have to use a static method to create the different monsters. Like that. Okay, let's just round it out just to finish up. Skeleton, skeleton, and last but certainly not least, the dragon. Okay, so all of them have a static create method that we should use to create an instance of that monster instead of going through the constructor. Oh, before that, one thing I didn't show, monster. I can currently not create instance of monster because it's not inherited from monster directly. Yep. Let's drop this condition. Now I can create a monster. Now let's make this abstract. So there is no way to construct it. And then we get this. So there are still rules that apply, even with reflections. Just be aware of these things. Let's just return that, and actually let's keep it abstract for the fun of it. You could also just check, by the way. So is abstract, and you don't create it anymore. You can also do things like what is interface. You can also do that. This class. So you make sure you don't accidentally try to make an instance of an enum. Things like that. So base type should exclude a lot of things already. But type has a couple of interesting flags that tell you more data about what you're dealing with. So static methods. Well, we do, instead of this call up here, we do what we did down there. We go for type.GetMethod. And we're gonna call the method create. All of our monster types have a create method. We just have to make sure that they really do have that, because the compiler doesn't enforce it. Then the flags, it's another public one, but this one is static. So it's not longer instance, it's static. And as for arguments, there are none. We just give it an empty array. Actually, this is new type 0. This is what I'm passing on, an empty array of types. It's just with the new language features, I can just do simpler like this. Same down here. This expects an array of types. This expects an array of objects. So this is just more convenient. With this, I'm trying to get create method, which can be null. If the monster doesn't have that, we can actually create a method is null, create a exception or throw an exception, another operation exception, monster type has no create method, that, and now we have to call it GetMethod.Invoke, just like we do with the greet method down here. Only this time it's a static method, so we can't give it any instance to perform the method on. Create method is static. It's another flag you could check, and it's static, so what we do instead is give it null. For every method, you either have an instance you call it on, if it's an instance-based method, or you have null if it's a static method and there is no instance backing it. And then we give it another empty array and call it as save castle to monster. Now technically we should not only check if it's null, we should also check for the return type. And we can make this a bit more involved. If we look for the return type, should be the type directly. That's how we defined it at least. So the create method and slime should return a slime, and mimic it should return a mimic. We could of course get a bit more obscure and test the return type if that's also a monster. So a slime might return some other type using the create method. Maybe you have some interesting mechanics where if you spawn a large group, the monster variant can change. Like we have different types of slime, and under certain conditions you might return not a slime directly, but a special slime. And so this might not be slime directly, but something else. But in any case, for us, this is how we define it. We have to have a create method that is public, static, doesn't get any arguments, and returns the type itself it's defined in. So yeah, public static returns a slime, it's called create. Doesn't have any arguments. So this entire definition is currently covered with this. Should also probably change this. Now we can create it. And let's just call it again. Let's go for slime once more. What did I miss? Okay, I made a mistake. Just which one? We have a slime return. It's the wrong type. That's correct. Create method is not. Oh, okay, that was, yeah. Not type, so it's supposed to be type, so if it's not type, we create the exception. Dumb mistake. So slime says hello, that worked. So even with a static constructor, it works. Could actually go a bit further. You could, for example, test for different create methods. Maybe there are some that accept parameters, and then you could provide something like a default value that is used if the create method, the static create method, accepts parameters. Stuff like that. Probably not very common, but it might happen, and this is just something you could do. You have full control over the code. You can see everything, and you can actually interact with everything. That's a danger, actually. And let's have a look at that. Let's go back to code up here. We go to monster.getType to get the type for our specific monster we have. So slime right now. And let's say private int in value. Like slime, let's make it a value that's set in the constructor. In value equals 10. So it's set in the constructor and it's private, so only inside slime can we actually see it. So if I go outside, slime dot in value doesn't work. Compiler complains because it is private. The compiler knows it exists. It is there. That's true, but currently it's prohibited to use. It's private. It's only in slime where we are allowed to interact with this. During runtime, however, we can use reflections to get the type, and then with type we can get field. Same as with GetMethod. Actually, in this case, we can make it simpler, though. What we're looking for is hidden value, if we know the name directly. And let's also specify the flags. It is instance-based, yes, but this one is non-public. The opposite of public, which gives us a field info. And this field info, if we find one, get value. It's like an invoke, only we request a value. So just like with invoke, we still have to provide the instance where we want to check for this specific field. Just like with method info, field info is just meta information. It is not directly tied to monster, it's tied to the type of monster. But with this, we get the value. So I get value 10. Even though it's private, I can I can access the data. That's not an issue. That's not that hidden. It gets worse, because I can just set the value, read the value, I can also set it. Spot myself there. Can set value for monster and then maybe make it -10. Let's go to the debugger again. Twice. So right now our monster is a slime. Let's look at the debugger here. Slime with a hidden value of 10. You can see it in the debugger. Now execute the set method, and suddenly it's -10. So the field hidden value is private. I have no access from the outside, and yet I can read and even write it. It gets even worse. Right now it's read-only. I'm only allowed to write it inside the constructor. If I were to try to set the value anywhere else, compiler would complain. It's a read-only. I'm not allowed to do that. However, reflections don't care. Reflections directly change the value. Read-only be damned. Can do the same for properties. So let's say this was used for a property, public and value. So previously it was this style, and then you convert that to an auto property, like that. Well, things are a bit harder to do now, but they can be done just the same. The thing is, properties and fields are different things. In the end, properties are like sugar that just hide a field that you have to access through get and set methods. But essentially, there's still a field attached to it. So get property. Let's remove that. So we get a property value. This one is public and instance based. And that gives us a property info. Again, metadata about a property, not the property info that's somehow attached to the monster directly we're looking at. And they don't have set value and get value. I mean, not really. What they have is a get method, which gives us a good old method info, and set method. Again, method info, because properties are just one or two methods, a get method, a set method, which then indirectly let you change a value through code, which lets you add some additional checks and balances in between setting an actual field. So property info directly has setter and getter methods, and if you haven't defined a setter, like in this case we only have the get, well, there is no setter. Property.info.set method would be empty. This returns a null, and there's no set value directly, only there is. Because in the end, properties are just fields in the background. You might be surprised by the result though. Let's go for -10 again. And yeah, might be null. Property set method not found. Yes, we did it! Properties are safe after all. Well, no, they aren't. Thing is, there's still a field in the background that we can't see directly, but it's the field that's backing up this auto property. We've hidden it, but it's there. The compiler knows it's there, the runtime knows it's there, and using reflections, we can know it's there as well. If we just go for all the fields in this type, let's get all the fields and just set a breakpoint there. It's currently empty. Let's set some properties we're looking for, instance-based and non-public. Let's try again. Oh, look at that. There is one field it found suddenly. It's a weird field. It's weird because the name isn't a valid name for a field. At least not for us as the mortal programmers we are. But the compiler can just edit. The IL doesn't care. So this entire thing, the value is part of the name, so it's less than value greater k underscore backing field. That is the actual name of this property. Of this field. So I can actually go type.getField and remove all of that. That's the full name of that field. And yeah, just setting the binding stuff again. It's instance based and non-public. Public. That will give us the field info, and field info set value is 10 for monster. Alternatively, we could also just go for field info's 0.setValue is 20. Let's ignore the properties. So we set the field info directly. We look at monster, it's -10. We can also indirectly, without knowing the name ahead, change the code to -20. So with reflections, you can circumvent the restrictions the compiler plays or puts on you, which is potentially dangerous. So even something like this, if everyone is coding with a good conscience and respects conventions and the compiler, then yeah, this is read-only. It's set during the creation of the instance once, and afterwards it's like a constant for the entire instance. It doesn't change, it's immutable. In reality, however, it is not immutable. If you have reflections, for example, you can absolutely change the value. And there are other ways you can mock with it as well. That's where we talk about references and pointers and whatnot, which I don't think I ever will. Nah. Or maybe as a side note somewhere. Anyway, reflections, very useful for dynamically working with your code. So doing stuff you cannot write in stone up ahead during compile time, or do not want to at least. You might not be able to because it has to interact with libraries you later on add dynamically. Like you can have something like an add-on or add-in, which is just an external library that's provided to your code and has to somehow work with that. And maybe in that case, you want to use reflections to get a quick view of what is this library I'm only now seeing for the first time during runtime, and how to interact with it. Or you just use it in places where you can't be bothered to write out the full code by hand, statically for everything. You want to have it work dynamically, so you can just create a new monster and everything just works. Be aware, however, that reflections do have a cost. For one, safety. The compiler doesn't check if you can or cannot do it. Reflections will just allow you to do. If it's possible, reflections will do it. If it's just not possible because a certain method doesn't exist, well, okay, sure, it will throw an exception or give you a null value, but otherwise it will not check if it's proper to do. It just checks if it's possible to do at all, and then it will let you break all the rules. Also, performance. Reflections are slow. Relatively. I mean, for me right now, I'm only creating a monster by hand, maybe one or two for testing and whatnot. So this doesn't really matter. But let's say I have some code that would have to run this method, I don't know, a couple of thousand times every second. Even if it's just happening once per minute, just a couple of thousand times calling this, that can actually cause lag. Reflections aren't fast. I mean, in human terms, they're fast, but in computer time, it's slow. And so you should avoid doing that in parts of your code that repeat a lot or need a lot of speed. There's a lot you can optimize. So for example, the first thing I should do, instead of doing type of, and it's the first thing because it's the easiest to implement. No, that's not what I wanted to have type of. So type of monster, type of stuff. Because type of itself takes a bit of time, so I can optimize here. Right? Like that. Same with string. I can store it somewhere, cache it. But beyond that, a bit more involved, I should start to cache. So for example, instead of calling all of this every time I run this class, I can make a simple static cache, like, okay, let's do private read-only, yeah, why not, dictionary, string, okay, that makes it a bit better at least, MethodInfo. Let's do it like this. If we go for our static methods, and then I'm doing static monster. Oh, forgot the static. My bad. Structures, let's do that. And then I can do that. Don't care about that. Monster, actually, that's, yeah, whatever. You could also store this in a static field and cache it. You could actually have classes that cache it. Actually, there might be default classes that do that already. Not too sure. You could also be clever with generics, where each generic also has its own unique representation of static values. So you can do stuff with that. But, no, wait. That's not what I want. That condition is out the window, don't care. Continue. Create method. Continue that. And otherwise, we're gonna add structures.add type.name and create method. Maybe like this. So in the static, okay, yeah, let's rename this. No, that's actually wrong. Let's do it like this. This is the static constructor for the class, so it's only called once, and it will cache all the methods we find inside this dictionary. So what we can do here is what's that? Constructors dot try get value monster type, not method info, create method like that. If not that, then throw the exception. Otherwise, okay, know what? Let's do it this way. Let's do the null down there. Yeah, that's better. This is prettier. So if it's not finding a constructor because we didn't have the type, or if the method doesn't work for some reason and we get a null back, we catch that here and get the exception, and then we can continue. I don't need this anymore. Took a bit of time, but this would be the slightly more efficient way. We cache all the stuff up here, and at least don't have to look up the types anymore and check them. We still have a MethodInfo object, which still means some lag when calling. So this can also be further improved. For things like this, you could wrap the method info in a delegate, and you can use the Roslyn compiler, different expressions, and actually build up code that calls it directly. Which I know that was just 2 or 3 lines of code, but I can't remember them specifically. I've only used that once and never really tried to keep that in my head. I would have to look that up again. But yeah, you can optimize it more. Most important is caching. Just best improvement is just by not having to call it at all. So the first slime can also use the cache already. Since the first time I call monster, the constructor itself will take a moment, but then any subsequent call will be pretty fast and benefit from the cache data. And let's, to close out, show you something else. Let's see. Let's say we don't want to use filter based on inheriting from monster. So we don't want direct descendants. I mean, you can also check if something is inheriting from monster somewhere further down the line, like if it's down the chain somewhere, if it's a child of a child of a child or something. You can check if there's an interface for monster, you can check for that. But we can use a feature we introduced a while back that had some cool uses already, but not if you made it yourself. Public. Monster attribute. Attribute. So I should add class. Okay, what's wrong with me today? Class, like that. That's better. So instead of inheriting from monster, which is still possible, I mean, let's mix and match, why not? I can just give it the attribute monster. So I give all my monsters here now the attribute. Some still inherit from monster, some don't. And now I can, instead of checking for the base type, let's pet type dot what's the guest custom attribute? Monster attribute. Now this is an extension method. You could try to do it the hard way and just actually go through the attributes, but this is the fastest way. Just with the generic get custom attribute extension. And this will give you the monster attribute if it is attached to your type. So keep in mind, type is just the meta information. It's not talking about a specific instance. It's talking about the class as a whole. So whatever type we're looking at, we're checking if it has an attribute applied to it, like we have here. And if that attribute is of type monster attribute, the one we defined ourselves, our own attribute. And if so, store it in here. And if it doesn't have an attribute of type monster attribute, then just store a null in here. And so what we can do instead is if monster attribute is null. And this would result in the same code basically. Let's just drop this and do this. Yeah. That didn't work. Why did it not work? What did I miss? What did I miss? Oh, create monster is trying to. Yeah, that's not how we do things. The save cast is ignoring it. So that's why. Set a breakpoint here. So we do have the create method that worked out fine. Just that when we invoke this, you can see it down here in the debugger. The invocation of the method did return working slime, but casting that to a monster, savecast, resulted in a null because it's not a subtype of monster anymore, so that's null. But generally it accepted slime. Instead of that, we should probably go for object now. Object. And remove the cast. And let's also drop the rest here. Don't need that. Actually, you know, let's keep it in here. Why not? So this up here is not mods anymore, it's object. Okay, now we got the slime though, as intended, because it's decorated with the monster attribute. If I drop this, what the? Okay, what is going on? Please don't make any changes that I don't want. Thank you. That's better. So attribute removed, and now we don't find it anymore because it doesn't exist. Interesting though, it's not just about the attribute itself. This attribute can have additional values. Public int group size. For example, public monster attribute and group size, yep, like that. And now using reflections, I get this attribute and I can actually get the group size. And in the create monster down here, we can actually, let's do that in here. Let's see if we can, what do we have? GetType.get custom attribute, monster attribute, yes, monster attribute. If that, then string rating equals no, let's rating equals monster attribute dot group size, else rating equals hello. And then we can put in the greeting in here. I mean, this shouldn't happen because we also already filtered for only a monster attribute, but just in case. Now, since the attribute has a constructor, we have to specify the value. So let's say slime start in groups of 5. Now mimics get 1, they are singular. Skeletons get a group of 2. And dragons, they are also boss monster, only 1. So I just decorated my different monsters with the monster attribute, which declares them as a type of monster as far as my dynamic code is concerned. And the monster attribute also provides a value that can be used during creation for something. And so when we create a slime, we get slime size, we are 5. And if we use the, what was it, the skeleton had the greet method as well, right? Let's try that again. We're only 2. And with Dragon, for example, of course, they don't have a greet method, so we don't see it, but they internally have access to the attribute with a value of 1. So monster attribute is our custom attribute, and using reflections, we can actually make use of this attribute as well. Like, this is one of the best uses I have for reflections. Decorate my code with custom attributes for very specific things, and then just use a reflection to read that data out. For example, I had a system where we would have custom classes with settings, just properties in there that represent different settings a user might make. And we used those in our code. Those were immutable classes that we shared around for the settings for a program. But at the same time, because we decorated the different attributes with a specific attribute, different properties with a specific attribute, we had some dynamic code that would generate the UI for a user to interface with those settings. So whenever we had some new setting we needed in our code, we just added to this one class and we decorated it with a specific attribute that would provide things like a tooltip. And so now we have this property in the code that we can use in our program, in our business logic. But at the same time, the dynamic part of the program would automatically add a new UI item for the setting that's presented to the user with that tooltip. Like, very useful in there. And going back to the very start, oh, hello there. We're about to finish. Sorry to say, we came right at the end. Just finishing rambles. Back to the start. The code generation I did there for quickly generating the data for the enum and the switch cases. Stuff like that can actually be somewhat professional, depending on the context, because you can use this reflection code not just in your own code, but also in programs that you use outside of your program specifically to generate code for you. And you could use them in the context of a custom build task. So your normal build would trigger actual C# code you write, and that can react to the code you have in your source code, and based on that generate more source code. That's a bit convoluted, but it's possible. There are also templates, I think, are supported by default, at least in Visual Studio, T4 templates that do stuff like that. And of course, nowadays you would probably talk about source generators, which are a class of their own. Source generators are a tool that was introduced that are doing exactly that. They're part of the build process, and they read your code that you wrote, and based on that generate more code. Personally, I don't use them so far, at least not custom source generators. I mean, there are language features on libraries I use that themselves rely on source generation sometimes, but the support isn't that great. At least the last time I tried to use custom source generation, it wasn't that great of an experience, so I'm still waiting for updates on that. But it is a cool feature if you want to look into that. Source generators, they're doing basically this. We read code from your program, generate C# files that are now also compiled with your program to extend it. So basically the very thing I did in the beginning manually, just a bit more integrated into the normal build flow. Cool stuff. But that's reflection. Homework. Try to go back to a project you did where you experimented with custom attributes or attributes in general, even if it's existing C# language attributes or standard library attributes, and write code that uses reflection to give you an overview where you've used attributes in your own code. So you write code that reads your own program during runtime and outputs in the debug or on the console or somewhere else a list of, let's say, classes that use attributes and what attributes those are, to get an overview of how your program uses attributes. All right, and that's it for today. Well, as I said, you joined a bit late. If you're interested, you can check the VODs. They're all up. At least I try to get them up as fast as I can, usually a day late. Or you can watch on Twitter, actually, the Twitch VODs. Yeah, and have a nice evening. Bye-bye.